Good evening. Let me start sharing with you why I'm so excited about this industry today. So, you know, I finished my studies some years ago in the university, and at that time I ended as engineer, industrial engineer, master in electronics and automation. And you know, by chance, I ended working in an industry that was called HVACR. Well, the reality was not by chance. It was because I was offered a job for project management, large installations in Canary Island, you know, big resorts, big installations, sun, beach, fun. So basically, it was an offer that I couldn't refuse. And then I entered into the world of the HVACR. So it was many years ago. And then, beside that, there was some automation that was engaging me. I easily discovered that I was really entering into the industry where water, pipes, air, ducts, refrigerants were really the king. But today, I'm really so excited because now is the time in which the electronics, the communication, the microprocessor, the sensors are really rising up in our industry and are going to be the king. So let me go through this presentation about smart equipment, new concept that is growing in our industry, and you will see very soon why this is going to be so important for our future. So let me start by addressing some topics about the industry we have, the building industry. Then I will talk a bit about us, people, human beings. And of course, I will dedicate some time to talk about the technology, things that we need in our industry to build the equipment that our customers need. So I will talk about the connection between these things. So the first thing that I think everybody knows now is that, you know, buildings account for 40% of the energy consumption in Europe. So it's huge, it's massive, the consumption that we have in the buildings. And the HVAC industry represents a big, big portion of this 40%. But it's on those buildings where we humans really live, work, have fun. So at the end of the day, we spend 90% of our time on the buildings. So I think everybody will agree that we as HVAC industry should work on the savings for those buildings, because everybody is aware of that. We need to save energy. But we need to do that in a way that do not sacrifice the comfort of the people that use the buildings. However, the challenge is to do it in a sustainable way. We need to make buildings sustainable at affordable cost. So we cannot do things that cost a fortune, in other words. So let's look to the building industries today. So our building industry is improving a lot. We all know that design has improved a lot. We have, in all our design, in all the building designs, energy is a key element on the equation. It's considered in every aspect of the building design. We are benefiting from new materials, new construction materials, things on isolations, on windows, many components that are really helping to make better buildings. And of course, when we look to our industry, our equipment are also improving. So we are benefiting from better materials that deliver better performance on the equipment, etc. But the reality is that when we look to our equipment and the technologies that we use today, I would say that you all agree that the fundamentals of the technologies that we use have not changed so much. I'm talking about the mechanics, I'm talking about the thermodynamics principles that are behind the operation of all this equipment. So there has not been a really big evolution. So let me now put you or play with an analogy, another industry. So I think we all would agree that the car industry is today one of the most advanced industries. So this industry has faced similar challenges, and I will tell about that. than the one that we have in our industry. The mechanics, the fundamentals of the operation of the devices, the cars has not changed so much. And I'm not talking only engines. Now we have the electric engines, but things on the other components, but also the motors. The motors still are the same. The wheels are the same. The brakes use the same operations. So the wheels, the driving wheels, they are using the same mechanics, the same principle, but they have improved a lot. They have improved a lot. So if we compare cars from the 80s with the current one today, and we look, for example, to the power that these cars use, we can easily say that in the 80s, having a 100 horsepower car was a big car. Today, it's equivalent to having a 200, because below that, there are many. It's a commodity to have now more than 100 horsepower car. So the car industry evolved from 100 to 200 at the same time that they were moving from a fuel consumption of roughly 20 liters to 5 liters per 100 kilometers. So there has been a huge evolution. So the technology has allowed them to improve the functionality of their equipment while decreasing the energy consumption. So there are opportunities. There are opportunities to do that. So what do you think has been the key for that great success? Principles are the same. What has really changed is the integration of the technologies, and in special, the incorporation of hundreds of sensors, the incorporation of the massive incorporation of the electronics into the equipment, into the cars. Today, cars have hundreds of sensors, hundreds of microprocessors that are working on every single element that is installed in the car. We hear about this, the fan, the motors. But the same here. So every single component in a car today has a microprocessor, has many sensors. And it's thanks to the integration of all this technology, the mechanics and the electronics, how they have been able to put every single device into the optimum operational efficiency point. And by doing that with every single component and integrating them together, they are able to deliver things like we saw before. So I really believe that this is our opportunity in our industry. We need to be much better on integrating technologies. Okay, so do you think you will buy a car by parts, knowing that all that technology that it incorporates? I believe nobody will buy a car by parts. Imagine the mechanic, and then a kit with the computer, another kit with the sensors, and then you install, and then you save some money. Okay? Nobody will do that, because you want all the parts completely assembled, fully tested, functionality granted. So you will never go in that direction. Well, I can tell you that in our industry today, we are still doing that. We buy systems, HVACR system by parts, in many instances of our industry. Think on a handling unit, fan coils, many components are like that. And that they are not benefiting from this integration of technologies. They cannot have hundreds of sensors, of course not, because you cannot install afterwards. They need to be installed on site, on the factory. Okay? So here is what our opportunity is. We need to improve this. We need to be much better on how we integrate technologies to finally deliver better equipment to the market. So if we move now and think on the buildings, again, everybody knows that in the last years there has been a very good improvement, and all large buildings are benefiting from complex and sophisticated BMS systems that at the end are delivering huge savings in operation and energy on the buildings. This is a given today. So all big buildings, airport, hospitals, big offices, all have a BMS system. And this is, as I said, a given. But what happened with the small and medium-sized buildings? That you can see account for big part of our stock, building stock what happened with them? Can they have a BMS? Well, can they have an affordable BMS? Because yes, they can have, but the problem is that they cannot pay because it's too expensive. When we go to the previous slide, big buildings, BMS, but at the end, they represent, if we go to the analogy of the car industry, they are the Rolls Royce. So the user, the owners, the consultants can go and say, okay, I want this, I want this, I want this, I want this, and the industry deliver the custom solution. When you go to the small and medium, it's like buying a commodity car. You have some options, but at the end, you get a car that works, that is effective, is efficient, don't consume a lot of gas, a lot of fuel, so it's good enough. And this is what we need on the buildings, on those buildings. And we don't have this solution yet. So on those buildings, what we need is to have smart equipment, intelligent chiller, intelligent boilers, intelligent fan coils, capable of communicating, sharing data, capable to be plugged together and interoperate. And with this, we are going to create this BMS system that the small size, medium size building demand. They will be small but smart, because they will interoperate in a plug-and-play mode, so zero engineering. No need to program things. They will connect, they will recognize, and they will run. So this is what we need. And to make this happen, we need this intelligence in our equipment. If not, this won't happen. And with this, we will deliver what the user needs to be able to run these buildings in the most effective way. On top of that, if we are able to have this intelligent equipment or smart small buildings, and we also leverage on IoT cloud, I'm a bit stressed about the previous presentation, but I firmly believe that this is the future. I think everybody believes that this is the future. We need to be ready for this threat. But the reality is that today is real, that we can connect, we can securely connect thousands of equipment, thousands of chillers, thousands of these small buildings together in big platforms that are collecting data, are allowing us to apply sophisticated technology, deep learning techniques, to create really algorithms that allow us to have self-diagnostics or preventive diagnostics, or many things that are really driving, again, buildings operation or equipment operation, or ensuring that these buildings or equipment are really running at the optimum operational efficiency point. So this is, again, another clear opportunity for our industry, and we need to move there. And to move there, again, intelligence in the equipment. If there is no intelligence in the equipment, forget to connect there securely. This is not about connecting and communicating with a simple bus. This is sophisticated, and we need to integrate these technologies into our equipment in our industry. So let's go and try to wrap up. I'm finishing now. And what is then our industry opportunity? So as you saw, I talk about the buildings, the industry, the building needs, how they consume the energy, the people, the needs of the people, the opportunity of our technology, how other industries have faced similar challenges than what we face today, and how they have succeeded. And what was the key for this success? As you remember, it was about integration of technology, adding electronic, adding sensor, what I studied, by the way. Adding all these components together with our mechanics will allow us to have higher intelligence in our equipment, creating this smart equipment that at the end can leverage, because of the capacity of the intelligence, on all these technologies that are available today, IoT, cloud, etc., to finally deliver fault detection and diagnostics, and many technologies, many features that really will drive even small buildings to the optimum operational efficiency point. So then, ladies and gentlemen, I think the challenge is in our hands, and the opportunity is in our hands, in our industry. And I can tell you, without these smart devices, we are not going to have a small, smart BMS system in the buildings. So we will not be able to deliver what the people is asking us, to save energy on the buildings. So we need to go there. And the opportunity is there. I presented one example of another industry, and it's real. And we have heard, and we are going to hear more about technology, communication, and we need to leverage on those technologies to be better, to really drive our industry to the new age. So welcome to the new era, the era of the smart equipment. Thank you for your attention.